came across an interesting video the other day which showed testing cheaper radios using a tiny SA but with the antenna plugged in. Now, generally the normal way that we test in sort of even in my review videos and in other review videos that you might have seen before is hooking up the radio such as this. This is my Kenwood, hooking it up through an attenuator through here straight into something like a tiny SA or a spectrum analyzer so that we can measure and have a look at the harmonic levels to see what we get out of them, so that to check if the second, third, fourth, etc. harmonic are clean, basically. So in the video there were some screenshots of the tiny SA, and what they've done is just hooked up, I believe, the stock antenna into the RF port of the tiny SA, and then got a clean, cheaper Chinese radio, hooked up an antenna, transmitted, and then had a look at the harmonic levels to see what was doing, and apparently the second and third harmonics looked pretty bad. So what I thought I would do is a little bit of a test of my own, and I'm going to do a couple of them. One here is with the Yaesu VX8, and I've also got my Kenwood here as well, the THD72. So as a bit of a control test, what I want to do is I want to do a test here. So I've just fired this up. This is on 146.575, and I've got that hooked up to my 20 dB attenuator because we're going to have 5 watts coming out of the radio here into the attenuator, and then we want to make sure that we're not going to blow the front of this tiny SA up. So that's going to reduce it by 20 dB, which is not quite enough. We need to reduce it down a little bit more because 5 watts is 37 dBm, and then we want to reduce it again here. This is another 20 dB attenuator, lower power level, but that's good. We're reducing the power enough here. We can reduce it enough here with this 20 dB attenuator, so we won't blow the front end of this up. So we've got 40 dB of attenuation, and what we're going to do is going to go into the tiny SA here. So what we'll do is we'll go into the level, and we'll put in some external gain of minus 40 dB so that we can account for that. That brings our trace up. So we can see 40, plus 40 here, minus 50 there. And what I'm going to do is I'm going to transmit here on the Kenwood, and we can have a look here. You can see this span here is from 140 megahertz all the way up to 800 megahertz. So we've got quite a wide span. And you can see there's our fundamental down here. If I bring my marker down close enough, I probably should reduce the span, but you can see there plus 37 dBm basically. But you can see there that this radio is pretty clean. There is nothing on the second, third harmonic here. If I cruise along, you can see it's all sort of at least, 50 dB down. There's no spurs popping up. The noise floor is just sitting there, so it's looking pretty good. So now what we want to do is I'm going to stop transmitting, and I'm going to now put the antenna on the tiny SA and also onto the radio, and we'll have another look and see what it looks like. And you'll notice that my noise floor comes up quite a bit. I've got a couple of signals popping up and down there. And just to explain a few, if I actually move my marker down, so these two down here, these are television at 170, 180 megs. There's a couple of channels there, so I'm obviously receiving those here in the shack, the carriers, the digital carriers. There's a couple of, looks like there's a little bit of a spur maybe here, which is that's about 420 megs. That might be another transmitter somewhere nearby here. I think there's one up the road. 480 megs, there's another transmitter there probably, but you can see that it's quite busy. There's a little bit of a noise floor happening. I'm receiving signals that are getting into here, okay? Now the other thing is that some of this noise floor as well might have come up due to, I've got lights in here, I've got LED fluoro lights, I've got lighting for my videos, I've got random boards that are running with oscillators in them. I've got an APRS transmitter here. I've got my Raspberry Pi and my other transmitters. So I've got probably a few potential noise source areas in here, and also I've got some metal around here. I've got my power leads, my switch mode power supply. So all of this contributes to the noise floor level. So just think about that concept there for a minute. So what I'm going to do is I'm going to transmit here on the same frequency, 146.575 on 5 watts, and just have a look here. So just remember that our fundamental will be down there on the left, and we're going to have our second harmonics and third harmonics here. So you can see there that I've got the fundamental here on the left, but notice here in the middle, and I'll just identify VK7HH, testing, you can see there that I have a spur on 439.8. 439.8 sitting at 0 dB. 439.8, that sounds very familiar. That sounds like a third harmonic, which is very interesting because we didn't have a third harmonic when we had it plugged in directly into the spectrum analyzer. So what's actually going on? As I move the antenna around here, as I transmit, I'm going to move the antenna around the area here where this antenna here is on the spectrum analyzer, around the LED light, and you'll notice there's a couple of other harmonics there popping up. There's a couple more, there's another one, there's that one here on that third harmonic. There's a couple of other spurs that are happening here. I'm just moving it around, and I've just in front here on the light. Now if I move it a little bit further away, if I've moved it far enough away, look at that, it all disappears. So I've moved that's about a meter away now. You can see, look, I can get it to vary up and down as I move the transmitter around. There we go, there's the antenna moving in front of the tiny SA. And you can just see the spurs here. Look, there's a couple coming up now. And we're getting all of this on a seemingly clean transmitter. Now, let me just adjust the span here down a little bit. Let's go and have a look at the second harmonic. So that's going to be around about 290 megahertz or something like that. Start that span. Let's stop it at about 305 or something like that. There we go. So now we're looking at a 290 to 305 in here. Now, what happens if we transmit on another radio here, 146.550, and we've got this radio on 146.575. If we transmit both at the same time, what do you think is going to happen? Well, let's transmit. Look at that. Oh boy, look at that spur. That's dirty. If I bring the transmitters closer together, look at that. If I move them away, that spur's still there. If I move them, if I spread them out right, I've got my arms a meter apart. Look, that spur's still there. If I move even further away from the camera and from the receiver, it's still there. If I keep going and move further and further away, it's still there. I'm still causing another spur. But both of these, and I've tested this Yaesu radio, this is clean, and this Kenwood is also clean. So what's actually going on here? Well, there's a little thing called intermodulation. So what happens is that when you get two or more transmitters transmitting on different frequencies, they can combine, they can sum, you get different products, you get different frequencies be generated when they're mixing in a non-linear fashion. So for instance, this receiver here on the Tiny SA must be getting overloaded because I'm so close with the transmitters. One transmitter's going into one's combining in the other, in the PA of the other, and then it's mixing and it's being re-radiated out on different frequencies, and it's being shown here on the Tiny SA by that spur right there. 50 megs to 600. So we've already got our noise floor, we've got all of our current stations that we can see, but as soon as we transmit, look, we've got that spur, we've got a third harmonic, we've got a primary, and as we get closer, they vary up and down, they get stronger. I don't believe it's because of a dirty transmitter, and as you can see that this radio, when we tested it on the Tiny SA, we didn't have any harmonics at all. So what I suspect is happening, now I might be completely wrong here, is that we're either A, getting a mix from this radio mixing with another RF signal, and it could be any RF signal, it could be an RF signal from another transmitter outside, it could be from signals that are being emitted inside my shack here, it could even be coupling, it could be coupling into my power wiring, my mains wiring, it could be coupling into a switch mode power supply, it could be coupling into a light, it could be coupling into all sorts of things. It could also just be overloading the Tiny SA because we don't have any attenuation, and in actual fact, it is worse than what it actually is, because we've got external gain of 40 dB. We've got emitters in our shack all over the place, and they can be emitted out, they can go into, we can transmit into them, they can couple back out, and we get RF just being spewed out all over the place. So, what's the takeaway from this? Well, the takeaway from it is now, I might be incorrect in saying this, so please let me know in the comments if I am, but I believe that the FCC rules as far as spurious emissions are concerned are to do with the transmitter up to the point of where the antenna is connected and not including the antenna, because obviously as part of this, you could be mixing inadvertently with other transmitters and radiating out on other frequencies. So it makes sense that as long as your transmitter is clean and you're not deliberately transmitting on another frequency, then with harmonics, then you're good. The likelihood of you interfering with others is probably pretty low, because as you can see is, even though I'm transmitting here and you can see those harmonics, that second harmonic is minus 40 dB. So it's not really going to radiate out too much, and it's going to vary in signal level as well. Now the other thing, not just the sum of these frequencies can be a problem as well. So if I was transmitting on, say, 146 and 145, then we could be seeing the sum of those frequencies appear, and I'll put a calculation up on the screen of what that actually is, as you saw earlier on the Tiny SA, but we also get the difference. Now the difference between these two is 1 megahertz. So if I transmit on 145 and transmit on 146, have a look on our Tiny SA. We get a spike at 1 megahertz. So that's also very interesting because of this intermodulation. As far as having a detuned antenna, I mean, no whip antenna on a handheld is going to be perfect. It's going to be, a bit of a compromise everywhere, but I'm not exactly sure that that's 100% the problem. If you're going to have sort of mismatches in impedances between the antenna and the radio, then yes, you may get some sort of harmonic relationship. But I think that at the end of the day, looking at this, it's just coupling that's happening, which is just my theory, might be completely wrong. Let me know what you think in the comments. The other thing too is I was very close to this Tiny SA. I was testing literally across the room, or even just a few centimeters away, especially with the two transmitters just running. So I was in very close proximity. I was putting the Tiny SA more than likely in a overloaded state, probably a non-linear state, and that's where we were getting mixing occurring as well. And mixing can occur on all sorts of things. We have this problem on repeater sites where we have a rusty bolt or a rusty tower, and we'll get our transmitter will combine with another transmitted signal. They will both combine together, and then all of a sudden we get mixes all over the place in that rusty joint. And the only way to fix it is get rid of the rusty joint, which sometimes is easier said than done. If you want to see some of my other tests that I've done as far as RF is concerned, then they'll appear on the screen.